Welcome back to Tech Talks Education. We are continuing with the mole concept, and remember we have been discussing moles in mostly solids and gases. But right now we are going to look at moles in solutions. Moles in solutions. So, as we go to look at moles in solutions, we need to understand what these solutions are. So, let us see what we call a solution. What we call a solution. So, we are going to look at a solution basing on how a solution is formed. So, in this case, a solution is a substance formed when a solute dissolves in a solvent. Now, mark you one thing. A solute can be a solid, it can even be a gas. So, if it is to dissolve, it must dissolve in a suitable solvent, in its own solvent. So it has to dissolve in a suitable solvent. Now, a solvent is a liquid in which a given solute can dissolve. So if a solute dissolves in a solution, that's when, in a solvent, that's when we get what we call a solution. So in a solution, a solute is supposed to dissolve in a solvent, and then we get what we call a solution. Now, let us look at solutions, the types of solutions. So when we are making a solution, sometimes we just pick a solute and add into a solvent, possibly stir, and we get a solution without knowing the amount of the solute which we have added. So that one gives us a type of solution which is called a non-standard solution. So I've just said that if we don't know the amount of solute which has been added to a given solvent to form a solution, then it means that we have formed a solution which is called a non-standard solution. Now, that amount of the solute which is added to a given volume to a solvent to produce a given volume of a solution, that one gives us what we call a concentration of the solution which has been formed. So, in a solution where we have the amount of the solute dissolved in a solvent to form that very solution not being known, that's what we call a non-standard solution. So the amount of the solute added to the solvent to form a given amount of the solution, that one is referred to as being the concentration of the solution. So since here we don't know the amount of the solute added, it means that we have a non-standard solution. It means that in a non-standard solution, we don't know the concentration. So, by definition, in this case, a non-standard solution is a solution whose concentration is not known. We don't know the concentration, which is the amount. The amount can be mass, can be moles of the solute which has been added to a solvent to produce a given amount or a given volume of the solution. That's what we call a non-standard solution, a solution whose concentration is not known. Then let us look at another type of solution which is called a standard solution. So, whereas a non-standard solution is a solution whose concentration is not known, it means that in a standard solution, we know the amount of the solute which has been added to the solvent to form a given volume of the solution. So that one is what we call a standard solution. So in a standard solution, we know the amount of the solute, that is, we know the concentration of that particular solution. It is a solution whose concentration is known. A solution whose concentration is known. So when you look at these two types of solutions, a non-standard solution and a standard solution, in this case our point of focus will be on a standard solution, a solution whose concentration is known. Now let us go ahead and look at what we call a concentration, or what we call concentration, because we have said that a standard solution on which our focus shall be is one whose concentration is known. So what is concentration? So concentration So I've just said that if I have a given solution which was made by dissolving a solute in a solvent, then if I know the amount of the solute, and that amount can be either mass or moles of the solute which has been dissolved in a solvent to form a given volume of the solution, then we say such a solution is called a standard solution. So in this case, a standard solution is a solution whose concentration is known. So concentration is the amount, and the amount in this case we are talking about is either mass or moles of a solute in a given volume of a solution. It is the amount of a solute in a given volume of a solution. The amount we are talking about here can be either mass or number of moles or moles of a solute, in this case in a certain volume of a solution. Can we see examples of concentration? Concentrations. I said that the amount of the solute we are talking about can be the mass of a solute or the number of moles of a solute in a given volume of a solution. Can we try to see this? If I have 12 grams of sodium hydroxide in 100 cubic centimeters of sodium hydroxide solution. This one is an expression of concentration. It means that I dissolve 12 grams of sodium hydroxide in the correct solvent, in this case, which is water. So it was dissolved in water to produce 100 cubic centimeters of sodium hydroxide solution. So this one is the concentration of this solution. In simple terms, I can express this concentration this way as being 12 grams per 100 cubic centimeters of sodium hydroxide solution. So I have 12 grams of sodium hydroxide in 100 cubic centimeters of sodium hydroxide solution. I dissolve 12 grams of sodium hydroxide in some amount of water, which is a solvent, to produce 100 cubic centimeters of the solution of sodium hydroxide. That one is a concentration. This one is in terms of mass. Can we also try to look at in terms of moles? I can have 0.5 mole of sulfuric acid in 250 cubic centimeters of sulfuric acid solution. So, in this case, we have seen that we have 0.5 mole of sulfuric acid in this volume, 250 cubic centimeters of the solution of sulfuric acid. So this mole here is also an amount, because we say that the mass of the solute can be either, the amount of the solute can be either mass or moles. So here we have a half a mole of sulfuric acid dissolved in water to make 250 cubic centimeters of the solution of sulfuric acid. This is also a concentration, and I can express this concentration in short form as being 0.5 mole per 250 cubic centimeters of sulfuric acid solution. So this is an expression of concentration as well. It is either the mass or the number of moles of a solute. The solutes we have dealt with in this case are sodium hydroxide and sulfuric acid in a given volume of a solution. So here we have used 100 cubic centimeters of sodium hydroxide solution, and here it is 250 cubic centimeters of sulfuric acid solution. Meaning that these solutions are now standard solutions because we know their concentration, that is the amount, mass or moles of the solute in that very amount of the solution. So that is what we call concentration. Remember, we are looking at what we call standard solutions. Solutions whose concentrations are known. And in this case, the concentration of a solution is the amount, that is the mass or the moles of a solute in a given volume of a solution. And that's what we call the concentration of a given solution. Now we are going to pick one special, there is one special type of concentration of a solution. One special type of concentration of a solution is called molarity. Look at the spelling very well. I have not said morality, it is molarity. Molarity. And this molarity is denoted by capital M. Capital M. So that is what we call the molarity of a solution, and we are going to discuss it in our next session. So thank you for watching. This is Tep Talks Education.